The next mechanism I want to do is the addition of a halogen to an alkene. The other ones, the addition of an alcohol to an alkene is very much like that of water. It's identical, really, to that of water. The one of water is pretty close to that of hydrohalic acid, HX. But the addition of X2, or bromine or halogen, is really different. And so I want to do that one. This time I'm going to do the simplest case scenario. That plus X, right? That's X2. Alright. So this one, in my opinion, finding the attacker and finding the target is not trivial. I do not think it is. Because you find the electrons. These look like these might be active electrons here, and we're oftentimes used to halogens. Shoot, they're electronegative, right? So we're expecting, you might be expecting that to be the electrons, but it's not. It's really the pi electrons. You may have to just sort of memorize that, be told that, and believe it. Okay, the pi electrons attack this atom, which leaves this other X goes off as a halide. No problem. Oops, it doesn't look like that. Sorry. This is the big deal. It doesn't look like that at all. It actually looks like this, which you're not going to like. Okay, and this is called the halonium intermediate. Alright, that's step one. There's a couple reasons we don't like that. Number one, you're not used to seeing a halide with a plus on it. Number two, you're not used to seeing a halide with two bonds to it. Number three, we're not used to seeing a three-membered ring. Nevertheless, that is the intermediate. Okay, so what do we have left here? That. Okay, can you guess what's going to happen here? So I'm giving you a hint by drawing it down here, aren't I? Okay, these electrons come here. Boom. And what do you got? Okay, and that's the product. That's the addition of X2. I should have started out by saying this is on page 257. And that's the addition of a halogen to that. Pretty ugly. Could be scary.